What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what the Apple filing protocol is. So let's get into it. In the landscape of file sharing protocols, the Apple filing protocol, this stands out as a key player for Apple devices. It was developed by Apple and AFP. It facilitates file services and network communication between Apple devices, making it an essential protocol for macOS environments. In this video, we're going to talk about the intricacies of AFP, explore its history, architecture, operation, and practical applications. All right, so first things first, what is the Apple filing protocol? So AFP, this is a proprietary network protocol designed to offer file services for macOS and classic macOS environments. It allows users to access and manage files on remote servers as if they were on their local machines, and AFP has been integral to Apple's ecosystem, providing seamless file sharing and network communication capabilities. And here's a quick history of AFP. So the history of AFP traces back to the early 1980s during the advent of network computing, and Apple introduced AFP as part of the Apple Talk networking protocol suite to facilitate file sharing between Macintosh computers. So here's a brief timeline of AFP's evolution. So back in the 80s, Apple Talk and AFP were introduced, providing networking and file sharing capabilities for Macintosh computers. In the 90s, AFP evolved with enhancements in performance and compatibility, becoming a core component of Apple's networking strategy. In the 2000s, AFP saw significant updates with the release of macOS 10, adapting to modern networking standards while maintaining compatibility with older systems. Then in the 2010s, AFP continued to evolve with the advent of more universal protocols like SMB or server message block. Its prominence began to fade, and Apple eventually shifted its focus towards SMB for file sharing, though AFP remains supported for compatibility reasons. Let's talk about the AFP architecture. So AFP, this operates on a client-server model where the client requests file services and the server provides access to those services. And the architecture of AFP includes the following components. So you have the AFP client. So the client initiates requests for file services from the AFP server, and this could be any macOS device that needs to access files on the network. Then you have the AFP server. So the server responds to the client request, providing access to files, directories, and other resources. And AFP servers, they can be dedicated file servers or any macOS device configured to share files. And then there's network transport. So AFP traditionally used Apple Talk for network transport, but later versions adopted TCP/IP to align with modern networking standards. All right, so moving on, let's talk about how AFP works. So AFP enables file sharing through a series of client-server interactions, ensuring secure and efficient access to remote files. And the workflow of AFP generally follows these steps. So first, you have the connection establishment. So the AFP client establishes a connection with the AFP server using TCP/IP, and the server then authenticates the client using various authentication methods, such as password-based authentication or Kerberos. Then you have what is called the session setup. So once authenticated, the client sets up a session with the server, establishing a secure communication channel for subsequent operations. Then you have file and directory access. So the client then sends requests to access files and directories, and these requests include operations like reading, writing, renaming, and deleting files. And then the server processes these requests and responds with the appropriate data or confirmation. After that, you have data transfer. So data is transferred between the client and server using AFP commands encapsulated in network packets. And AFP supports various operations to ensure efficient data transfer, such as read-write commands, file locking, and attribute manipulation. And then after all of that is said and done, you have the session termination. So when the client no longer needs access to the server, it terminates the session, and the server closes the connection, ensuring that resources are properly released. And here are the key features of AFP. First is file sharing. So AFP allows seamless sharing of files and directories between macOS devices, supporting a variety of file operations. There's access control. So AFP supports robust access control mechanisms, which allows admins to set up permissions on files and directories to control access. You have resource forks and extended attributes. So AFP supports resource forks and extended attributes, which are essential for maintaining file metadata and compatibility with macOS applications. There's Unicode support. So AFP supports Unicode, which enables the use of international characters in file and directory names. There's authentication. So AFP provides multiple authentication methods, including clear text passwords, encrypted passwords, and Kerberos, ensuring secure access to shared resources. And then you have AFP over TCP/IP. So modern versions of AFP, they use TCP/IP for network transport, ensuring compatibility with contemporary networking environments and improving performance. All right, so let's quickly go over the AFP versions and their enhancements. So you have AFP 1.0. This was the original version that was introduced with Apple Talk, providing basic file sharing capabilities. AFP 2.0, this introduced support for large volumes and improved performance. AFP 3.0, this added support for long file names, Unicode, and larger file sizes, which aligns with modern file system requirements. AFP 3.1, this enhanced security with support for Kerberos authentication and stronger encryption. AFP 3.2, this introduced support for extended attributes, allowing for more detailed file metadata. And you have AFP 3.3, this improved performance and compatibility with modern macOS versions, providing better integration with TCP/IP. All right, so let's talk about the benefits of AFP. So AFP offers numerous benefits that have made it a preferred protocol for macOS environments. The first one is seamless integration. So AFP is deeply integrated with macOS, providing a seamless file sharing experience for Apple devices. There's rich metadata support. So it supports resource forks and extended attributes, preserving file metadata, which is crucial for Mac OS applications. There's enhanced security. It provides robust authentication and encryption methods, ensuring secure access to shared resources. There's performance. So AFP is optimized for macOS, offering efficient data transfer and low latency, particularly in Apple-centric networks. And then there's backwards compatibility. So AFP maintains compatibility with older macOS versions, ensuring that legacy systems can still access shared resources. All right, next, let's talk about the practical applications of AFP. So AFP is widely used in various scenarios to facilitate file sharing and collaboration in macOS environments. And the first environment is corporate networks. So in corporate networks, AFP enables seamless file sharing and collaboration between macOS devices, enhancing productivity and communication. You have educational institutions, so schools and universities. They use AFP to provide students and faculty with access to shared resources, such as course materials and research documents. You have creative industries. So AFP is popular in the creative space, such as graphic design and video production, where it preserves file metadata and ensures efficient data transfer. And then you have home networks. So it is commonly used in home networks to share files and media between family members with Apple devices. All right, so let's move on and quickly talk about how to implement AFP. So implementing AFP, this involves configuring both the server and client components to enable file sharing. So here's a quick step-by-step guide on how to do that. First thing you want to do is set up the AFP server. So you want to enable AFP on the macOS server by configuring the file sharing settings in the system preferences. And then you want to add shared folders and set the appropriate permissions to control access. Then after that, you want to configure the AFP clients. So you want to ensure that AFP client support is enabled on the devices that will access the shared resources. So you want to connect to the AFP server by selecting Go, then connect to the server in the Finder and entering the server's address. After that, there's authentication and security. So you want to implement authentication mechanisms to control access to shared resources. And this can include local accounts, network accounts, or Kerberos authentication. And then you want to enable encryption to secure data that is transferred over the network. Then after you do all that, you want to do some monitoring and maintenance. So you want to regularly monitor AFP activity to ensure that shared resources are accessible and secure. And then you want to update AFP configurations and software to address any vulnerabilities and improve performance. All right, so next let's talk about some of the challenges and considerations. So while AFP offers numerous benefits, there are also challenges and considerations to keep in mind. The first is the transition to SMB, or the server message block. So with Apple's shift towards SMB for file sharing, organizations may need to transition from AFP to SMB to ensure compatibility with modern macOS versions. There's performance overhead. So AFP's rich metadata support can introduce performance overhead. So you want to balance performance and metadata requirements that are based on the specific use case. There might be some compatibility issues, so you want to ensure compatibility between different macOS versions and AFP implementations to avoid connectivity and performance issues. And then there's security, so you want to implement additional security measures to protect AFP servers and data, particularly in environments where AFP is used alongside other file sharing protocols. All right, so let's wrap all this wonderful information up. The Apple filing protocol. This is a vital component of macOS networking, providing robust file sharing capabilities for Apple devices. With this rich feature set, seamless integration, and enhanced security, AFP remains a preferred protocol in many macOS environments. Now, understanding and implementing AFP effectively, this can significantly enhance collaboration, resource sharing, and operational efficiency in networks that are dominated by Apple devices. And as networking technologies continue to evolve, AFP's legacy of reliable and efficient file sharing remains a testament to its importance in the Apple ecosystem. And while the shift towards more universal protocols like SMB is ongoing, AFP's role in the history and functionality of macOS networking is undeniably significant.